AP Physics, we're on to lesson 15 in the summer program, and this is on energy. So what is energy? Energy is defined as the capacity to do work. What are the units of measure for energy? Energy has the same units of measure as work, and this unit of measure is called a joule. And that unit of measure for energy appears all throughout physics. Electrical energy is measured in joules, sound energy can be measured in joules, light energy can be measured in joules. You'll come across that word in chemistry. So the fact that energy can be converted from one form to another implies that they all have the same units of measure, and that unit of measure is called a joule. So what kinds of energy are there? There are two kinds of energy that we're going to be dealing with: kinetic energy, Ke, and potential energy, Pe. What is kinetic energy? Kinetic energy is the energy of an object in motion. What is potential energy? Potential energy is the energy an object has that can be converted into kinetic energy, but has not yet done so. And what is total mechanical energy? Together, kinetic energy and potential energy combine to create total mechanical energy. Sometimes we refer to it as total energy, sometimes as mechanical energy. Generally, the advanced placement exam refers to it as mechanical energy. What is gravitational potential energy? Gravitational potential energy is the energy contained in an object due to the Earth's gravitational force. The formula for gravitational potential energy is potential energy equals mass times the gravitational acceleration, which is 10 meters per second squared, times the height that the object is off the ground, and that would be measured in some unit of distance. Height is a type of distance. The formula for kinetic energy of an object is Ke equals 1/2 mass times velocity squared. Again, the velocity can be constantly changing, so you want to use the instantaneous velocity at this particular moment that you're measuring the kinetic energy. So what is the kinetic energy of a 12 kilogram shopping cart moving at 3 meters per second? So you simply plug in the numbers. 1/2 times 20 times 3 squared, so you always square the 3 first and then do the multiplications, and that would give you 90 joules of kinetic energy. Mechanical energy, also called total energy, is kinetic energy added to potential energy, or Me equals Ke plus Pe. If potential energy is 10 joules and kinetic energy is 7 joules, what is the mechanical energy? Simply 10 plus 7 equals 17 joules. Example of gravitational potential energy. A 2 kilogram ball is held 3 meters above the ground. What is the ball's potential energy? Well, you're looking for potential energy. The mass is 2 kilograms, the height is 3 meters, the gravitational acceleration is 10. So you simply plug in the numbers and you'd get a potential energy of 60 joules. What is the ball's kinetic energy? Kinetic energy equals, well, the velocity, if the ball is being held, is 0 meters per second. So we'll go ahead and plug the numbers in, and you get a kinetic energy of 0. So if the object is not moving, it does not have any kinetic energy. So what is the mechanical energy in the ball? So the potential energy we computed at 60 joules. The kinetic energy when the ball was being held is 0 joules. So you add those two numbers together and you get the mechanical energy of 60 joules. The law of conservation of energy states that the mechanical energy of a falling object does not change while it is falling. So Ke plus Pe equals constant. It stays the same while it's falling. So now we're going to do an exercise where we hold the ball 4 meters above the ground, and we're going to compute its potential energy, kinetic energy, and mechanical energy, and see how these relate. So a 3 kilogram ball is held 4 meters above the ground and then dropped. Fill in the blanks for the energy as the ball as it falls. Okay, so there's the formula over on the right for potential energy. Mass times gravitational acceleration times height. So at 4 meters, It's 3 is the mass, gravitational acceleration is 10. Those two numbers won't change. And initially it's at a height of 4 meters, so 3 times 10 times 4 is 120 joules. Now we go down to 3 meters. It's fallen to 3 meters. So the 3 and the 10 stay the same, mass and gravitational acceleration, but now it's 3 meters high, so that'll give you 90 joules. It falls to 2 meters. 3 times 10 times 2 gives you 60 joules. When it reaches 1 meter, 3 times 10 times 1 gives you 30 joules. And just before it hits the ground, it hasn't hit the ground yet, but it's effectively right at ground level, is going to be 3 times 10 times 0 is 0 joules. Okay, now, what do we know about kinetic energy? At the very top, when the ball is being held, it has no kinetic energy. It hasn't been dropped yet. So that becomes 0 joules. And using those two numbers, 120 and 0, we can compute the total mechanical energy of the ball at that height, which is 120 joules. And what we said with regard to the law of conservation of energy is that 120 stays in the ball all the way down as it falls. So it has 120 joules of mechanical energy. What happens to that energy when it hits the ground? Well, the energy is released. It can cause the ball to bounce, so some of the energy is put back into the ball. It could cause a sound when the ball hits the ground, so that would be energy as well. If it's something made out of metal, it could cause a spark. There's different ways that energy can be released. A little bit, even though it's something you couldn't feel, is being released as heat energy. All right, so now we have just that middle column to fill in. So we know that 90 plus that unknown number at 3 meters is going to equal 120, so that number must be 30 joules. At 2 meters, 60 plus 60 equals 120. At 1 meter, 30 plus 90 equals 120. And just before it hits the ground, 0 plus 120 equals 120. So you can see that the energy began entirely as potential energy, and by the time the ball got down to the ground, all the energy had been converted into kinetic energy. All right, and that takes care of our lesson on energy.